Okay, so you open up your favorite app on your Android phone, and boom, there's all your stuff, right?
Yep, all your settings, your preferences, maybe some saved games, your shopping cart.
Your to-do list. I mean, where does it all live? How does your phone actually remember all that information? Well, that's exactly what we're going to unpack today, learner. We're going deep on how Android apps store data locally, and we've got this awesome document that breaks down the whole process.
Yeah, it walks us through two big approaches. First, the rock-solid foundation that is SQLite databases.
Right.
And then it introduces Room, which is like a more streamlined kind of modern layer built right on top of SQLite.
So by the end of this deep dive, you'll have a solid grasp on how your apps manage all that personal data without needing to be, a coding guru or anything.
Absolutely. We're going to keep it practical and easy to follow. So buckle up.
All right, let's start with the basics, the bedrock, SQLite. Our document really emphasizes that Android has built-in support for SQLite, which is a pretty big deal. What it means is that app developers have this powerful tool right at their fingertips without having to bring in anything extra. And SQLite, for those who might not know, it's what's called a relational database.
Right, and that basically means that data is organized into these neat little tables.
Like spreadsheets, I guess, with rows and columns.
Exactly, rows and columns. And you can even define relationships between these tables. So imagine you have a table for, say, all your contacts and then another table for all the messages they sent you. You can link those two together, using what's called a foreign key, so the database knows how those pieces of information are connected.
Oh, interesting. So it's not just a bunch of random data floating around. It's all neatly structured and connected.
Yeah, it's all about those relationships, man. And Android provides a whole package, set of tools for working with SQLite. It's called android.database.sqlite, which, it's a bit of a mouthful, but it's basically the toolkit developers use to get the job done.
So you've got your Android phone, you've got SQLite ready to go. Now you need to actually create a database, and then you need to manage it, right?
Yeah, and that's where SQLite Open Helper comes in. This is a really handy class that Android provides. Think of it like your database's personal assistant.
A little helper, like a little robot that keeps everything organized?
Exactly. It handles pretty much the entire life cycle of your database.
Mm-hmm.
So when your app first runs and it needs a database, SQLite Open Helper is there to create it.
Okay.
Then, as your app evolves, so maybe you need to change the structure of your database, add new tables, or modify existing ones, SQLite Open Helper is there to manage all those versions and upgrades.
So it's like version control for your database.
Exactly. It keeps track of those changes so everything stays consistent and, prevents your app from crashing because the database is out of whack.
That's super important. So SQLite Open Helper is like the project manager, making sure the database is built correctly and upgraded smoothly.
Totally. But then comes the actual work, right?
Yeah.
Putting data in, getting data out, changing it, deleting it, all those nitty-gritty operations. And for that, you use an SQLite database object.
Okay, so this is our direct line to the data itself.
Precisely. It's your tool for performing all those CRU'd operations. Create, read, update, delete.
So you've got SQLite Open Helper setting up the stage, and then SQLite database lets you perform on that stage.
Yeah, great analogy. Now, there are a few ways an app can get hold of one of these SQLite database objects. Like one very direct way is just using the static methods of the SQLite database class itself.
Static methods, huh? So these are methods that are built right into the class. You don't need to create a separate object to use them.
Right, you got it. So you have things like Open Database, which you would use if your app already knows the database exists and you just need to open it up.
Gotcha.
And you have Open to Create Database. This one's cool because the database doesn't exist. It'll create it for you.
Nice.
So it's kind of a shortcut, a convenient way to get things going.
So a couple ways to get that direct connection, but our source also points out that the context class, that's like the heart of an Android app, it's linked to the system. It also has an open or create a database method.
Yeah, you're right. It seems like Android gives you multiple ways to achieve the same goal, which can be, a little confusing at times. But hey, flexibility, right?
Right, options are good. But I'm guessing there's a preferred way to do this, especially when you're using that handy SQLite Open Helper.
You bet. And that's through the getReadable database and getWritable database methods of SQLite Open Helper.
Okay, so these are methods specific to SQLite Open Helper.
Yep. Now, getReadable database, as you might guess, gives you a database connection that's only for reading data. So if your app just needs to display some information from the database, that's the one you'd use.
Makes sense.
But if your app needs to make changes, insert new data, update existing data, or delete stuff, then you need to use getWritable database.
All right, so read-only versus read-write access.
Yeah, pretty straightforward. And the real beauty of using SQLite Open Helper here is that it automatically handles the initial creation or opening of the database for you.
Ah, okay, so it's kind of like a one-stop shop. You tell SQLite Open Helper what you need, and it takes care of all the background work.
Exactly. It streamlines the whole process and makes life easier for the developer.
So we've got our database set up, we're connected to it, we're ready to rock and roll. But eventually, our app is done with the database for now. What's the best practice here? Just like disconnecting from the internet when you're not using it.
You nailed it. It's super important to close that database connection when you're done with it. And that's as simple as calling the close method on your SQL database object.
Like hanging up the phone after a conversation.
Exactly. By closing the connection, you release those resources back to the system and prevent any potential, weirdness or errors that might crop up later on.
So always remember to close the connection.
Got it. Now let's talk about the types of information you can actually store in these SQLite databases. I know databases have different ways of representing data.
Right. And SQLite keeps it pretty simple with a few basic data types. So you've got integer, which is for, whole numbers 1, 2, 3, 100, a million. Then you have real, which is for numbers with decimals like 3.14 or 2.718.
Okay, so the math folks are covered.
Yeah, totally. Then there's text-t, which is, as you might guess, for storing text. Could be a short string like a name or a whole paragraph, even a whole book if you want to go crazy.
And finally, we have BLOB, which is a bit mysterious. Yeah, BLOB stands for binary large object. It's basically for storing raw binary data like, images, audio files, video files, that kind of stuff.
So if you want to store a picture of your cat in your database, you'd use BLB.
Precisely. So these 4 data types, integer, real, text, and blobby, they're the basic building blocks for pretty much any kind of information your app might need to store.
Pretty versatile, right?
Yeah, it covers a lot of ground. But, like anything in life, SQLite isn't perfect. It does have its limitations. Our document highlights a few of these, and I think they're worth pointing out, especially if you're coming from a background of working with, more robust enterprise-level databases.
Right, so maybe there are things you're used to doing in those big systems that you can't do in SQLite.
Exactly. One thing is that SQLite doesn't support all the fancy ways of combining data from different tables that you might find in those bigger databases. It's kind of limited in terms of the types of joins it can perform.
Joins. So, taking data from 2 separate tables and merging it together based on some common criteria.
Right. If you wanted to get a list of all your contacts and the last message they sent you, you'd use a join to combine data from the contacts table and the messages table. SQLite can do some basic joins, but it can't handle all the more complex scenarios that you might find in, like a SQL server or an Oracle database.
Gotcha. So there are limitations to how you can combine data.
Yeah. Another thing is that SQLite, by default, it doesn't fully enforce what are called referential integrity constraints. Yeah. And these are, they're kind of important in databases to ensure that relationships between tables make sense and stay consistent.
So, making sure you don't accidentally delete a record that's still being referenced by another record.
That's a good example. Going back to our contacts and messages, you wouldn't want to delete a contact if there were still messages associated with him in the database.
Right, we kind of break things.
Yeah, exactly. In a database with full referential integrity, it wouldn't even let you do that. SQLite doesn't enforce this automatically, so the developer, the person writing the app, has to be extra careful and handle those relationships correctly in their code.
Okay, so it puts more responsibility on the developer to make sure the data stays consistent?
Yeah, it's a bit more hands-on. And one more thing to be aware of is that SQLite doesn't support nested transactions.
Nested transactions. Now we're getting fancy.
Well, it's not that complicated. A transaction is basically a way of grouping a bunch of database operations together, and either all of them succeed or none of them do. It's like an all-or-nothing approach.
Okay, so if one operation fails, the whole thing gets rolled back.
Exactly. Now, nested transactions would mean, having transactions within transactions, which can get pretty complex. SQLite just doesn't support that. So if you're dealing with a series of database operations that need to happen together, you have to handle that at the app level.
Okay, so those are some things to be mindful of when we're working with SQLite. It's powerful, but it does have its quirks. But hey, now that we know those quirks, we can work with them, right?
Absolutely. Being aware of these limitations helps you write better, more robust apps. Okay, so we've talked about creating databases, connecting to them, understanding data types, and even some of SQLite's limitations. Now let's get to the real action. how do you actually do things with a database? Like, how do you tell it to create a new table or fetch some data?
Right. So we're going beyond the setup and actually interacting with the database. What tools do we have for that?
Well, the most fundamental way is using SQL, the structured query language, so the language that databases understand. And there are specific commands for creating tables, inserting data, retrieving data, and so on. And in Android, you have methods like exec.sql and raw query to execute those SQL commands.
Okay, so these are methods of the SQLite database object that we talked about earlier.
You got it. So exec.sql, this one's used for SQL statements that don't return any data. It's like when you're setting up the structure of your database. Like if you wanted to create a new table to store all your, favorite cat pictures.
Excellent.
You'd use exec.sql to send that create table command to the database. Or if you wanted to add an index to a table to make searching faster, that's another case where you'd use exec.sql.
So it's for structural changes to the database itself.
Precisely. Now, raw query is used when you want to actually get data out of the database. You write your SQL query, that's like a question you're asking the database, and you pass it to raw query, and the database responds with a cursor.
A cursor? What's that?
A cursor is basically a pointer to the set of results that your query returned. Like, imagine you have a huge table with thousands of rows, and your query only selects, say, 10 rows that match your criteria. The cursor is like a little arrow that points to those 10 rows.
Okay, so it's like a handle that you can use to access the results of your query.
Exactly. And the cursor comes with a bunch of methods that allow you to move through the results, get the data from each row, and so on. We'll talk about those in a bit.
It sounds interesting. So we have exec.sql for making changes to the database structure and raw query, for getting data out. And I noticed our document also mentions some specialized methods for convenience. It lists query, insert, update, and delete.
You're right. These are like higher-level methods that wrap some of the common SQL operations, making life a bit easier for the developer. Instead of writing raw SQL every time, you can use these methods, and they kind of translate your request into the appropriate SQL under the hood.
Nice. So it's like having a translator that speaks both SQL and, whatever programming language you're using.
Yeah, that's a good way to put it. And they also make your code a bit cleaner and, less prone to errors.
Okay, let's walk through how these specialized methods work. Let's start with inserting data. How do you put new information into a database table?
All right, for that, you'd use the insert method. You give it the name of the table you want to add data to, and then you pass in what's called a null column hack.
Null column hack? That sounds a bit intimidating.
Yeah, I know, it's a weird name. It's basically a quirk of SQL that you have to deal with in certain situations. Like, imagine you want to insert a completely empty row into a table, but that table doesn't allow any of its columns to be null.
Right, so every column has to have some value.
Exactly. In that case, you need to provide the name of a nullable column as the null column hack. It's like a little trick to tell SQLite, hey, I know I'm not providing values for all the columns, but please insert this empty row anyway.
Okay, so it's like a workaround for a specific scenario, but in most cases, you just pass null for the null column hack, right?
Yeah, exactly. Now, the actual data that you want to insert goes into a content values object. This is like a key value store where the keys are the names of the columns in your table, and the values are the actual data you want to put in those columns.
Yeah. So like if you had a table for contacts, the keys would be name, phone number, email, and so on. And the values would be the actual name, phone number, and email of the person you're adding.
Exactly. You use the put method of content values to add each key value pair. And then you just pass this content values object to the insert method, along with the table name and that optional null column hack. And when you execute that insert method, the database nicely adds a new row with your data to the table, and it returns a long value, which is the ID of that new row.
Ah, so it gives you back a unique identifier for the row you just inserted. Handy. So that's how you get data in. Now, how do you get specific data out?
Well, for that, you've got the query method. It's a bit more involved than insert because you have a lot more options for specifying what data you want to retrieve.
More control, I guess.
Definitely. So with query, you provide the name of the table you're querying, and then you can specify an array of strings representing the columns you want to select.
So if you only wanted the names and email addresses from a contacts table, you just pass in those two column names.
Exactly. And then you have the selection criteria, which is basically your where clause in SQL. This is where you specify the conditions that the rows you want to retrieve must meet.
But give me all the contacts whose last name starts with S.
Exactly. And you can use placeholders in your where clause and then provide the actual values as separate arguments to the query method. It helps prevent SQL injection attacks, which, security is important.
Right. Always
Yeah.
good to be mindful of security. So you've got your table name, your columns, your selection criteria. Anything else?
Well, you can also specify grouping and ordering. So if you wanted to group your results by, say, the first letter of the last name, and then order them alphabetically within each group, you could do that with query.
Fancy. So it's a
Yeah.
pretty powerful method for getting exactly the data you want.
It is. And just like raw query, the query method gives you back a cursor object, pointing to the rows that matched your criteria.
So now we've got this cursor. How do we actually work with it? It's like we've asked the database a question and it's given us this cursor as the answer. How do we read the answer?
Okay, so a cursor is essentially a pointer to a set of rows, right? And it has all these helpful methods for navigating through those rows and extracting the data. So you have methods like move to next, which, as you might guess, moves the cursor to the next row in the result set.
Like flipping to the next page in a book.
Yeah, that's a good analogy. And then you have move to previous to go back a row, move to
Yeah.
first to jump to the very first row, and move to last to jump to the last row. So you have a lot of flexibility in how you move through the results.
You're not stuck going one by one. You can jump around as needed.
Precisely. And then, it's important to know where you are in the cursor. So you have methods like is first to check if you're on the first row, I last to check if you're on the last row, and even is before first and is after last to see if you've gone past the boundaries of the result set.
So those are like safety checks to make sure you're not trying to read data from a place that doesn't exist.
Exactly. They help prevent, those pesky null pointer exceptions that can crash your app.
Good to know. Now, once you're on the row you're interested in, how do you get the actual data from the columns?
For that, the cursor provides a whole bunch of get methods, each tailored to a specific data type. So you have get int to get an integer value from a column, get string to get a text value, get floating point numbers, get double for doubles, and so on.
So you've got a get method for every SQLite data type we talked about earlier.
Exactly. But here's the catch you typically need to provide the index of the column you want to get the data from. So if you requested 3 columns in your query, they'll be numbered 0, 1, and 2.
Ah, so you need to know the order in which you requested the columns to access them correctly.
Right. And if you forget the order or if it changes, you might end up getting the wrong data, which can lead to, unexpected behavior in your app.
Okay, so it's important to keep track of that order.
Yeah, it's a detail that can trip you up if you're not careful. But luckily, the cursor also has methods like get column name, which, as you might guess, gives you the name of the column at a particular index. And then you have get column index, which does the opposite. It gives you the index of a column given its name.
So you can use those to look up the index of a column by its name rather than relying on those hard-coded positions.
Precisely. That makes your code a bit more robust and less prone to breaking if you change the order of columns in your query later on.
Makes sense. And our document also points out that the cursor has a get count method, which tells you the total number of rows returned by your query.
Right. That's useful if you need to know how many results you're dealing with, maybe to display a count to the user or something.
So that's how you work with the cursor to navigate and extract data. Pretty powerful stuff. We've covered inserting data with insert, retrieving data with query, and now let's talk about updating existing data. How do you make changes to data that's already in the database?
Well, that's where the update method comes in. It's actually pretty similar to insert. Yeah. You provide the table name, you create a content values object with the new values you want to set, and you specify which rows should be updated using a where clause.
Okay, so same idea as with selecting data, you use a where clause to pinpoint the exact rows you want to modify.
Exactly. It's super important to use a where clause with update
Yeah.
because otherwise you'll end up updating every single row in the table, which is probably not what you want.
Yeah, that could be disastrous. So always be specific about which rows to update.
Always. And just like the other methods, update gives you some feedback. It returns an integer telling you how many rows were actually modified. So if you expected to update 1 row and you get back 0, you know something's not right.
Great way to check if things worked as expected. And finally, we have deleting data. How do you get rid of information you don't need anymore?
For that, you use the delete method. And again, it's pretty straightforward. You provide the table name, and you can optionally provide a where clause to specify which rows to delete.
Okay, so same pattern as with updating. If you don't provide a where clause, it wipes out the whole table.
Exactly. Be very, very careful with that. And just like update deletes the number of rows that were deleted. So
Yeah,
if it was successful and how many rows were affected.
Awesome. Okay, so we've covered a lot of ground here with SQLite. We've seen how to create databases, connect to them, understand the different data types, and perform all the basic see or read operations using those specialized methods.
We've even touched upon some of SQLite's limitations, which, it's important to be aware of those so you don't run into surprises down the road.
Absolutely. But now our document takes us to a whole new level room. This is described as an abstraction layer over SQLite, an OR.
Yeah, it sounds a bit technical,
Yep.
but the idea behind Rune is actually quite simple. It's all about making working with SQLite easier, more intuitive, and, less error-prone.
So it's like a more user-friendly interface for SQLite.
Exactly. Think of it like this. You're driving a car, right? You don't need to know every single detail about how the engine works, how the transmission functions, all the intricate mechanics.
Right. I just need to know how to steer, accelerate, and brake.
Precisely. Room is like that.
Yeah.
It provides a higher level interface to SQL, abstracting away a lot of the low level details so you can focus on what you want to do with your data rather than how to do it with SQL.
Okay, so less SQL, more focus on the data itself. And this ORM part, object relational mapper, what's that all about?
Well, most programming languages like Java or Kotlin, they deal with data in the form of objects, right?
Yes.
You have classes, you have instances of those classes, and so on. But in a database, data is stored in tables and rows.
So there's a bit of a mismatch there, a difference in how data is represented.
Exactly. And an ORM is like a bridge between those two worlds. It maps your objects in your code to the tables and rows in your database. So you can work with your data in a way that feels more natural to your programming language, and Room takes care of translating that into SQL behind the scenes.
Okay, so less mental gymnastics, less switching back and forth between different ways of thinking about data.
Yep. And Room also uses annotations to do this mapping, which makes your code cleaner and easier to read.
Annotations, those little markers you can add to your code, I've seen those.
Right. So in Room, you use annotations to tell it how your classes relate to your database tables, how the fields in your classes correspond to the columns in your tables, and so on.
So it's like providing Room with a map, a blueprint of how everything fits together.
Exactly. And the beauty of this is that it's all type safe. So if you make a mistake in your annotations, or if you try to access data in a way that doesn't match your database structure, Rune will catch it at compile time.
Ah, so it prevents errors from even happening in the first place.
Exactly. It's a lot safer and more reliable than writing raw SQL, where you might not catch those errors until runtime, and then your app crashes.
Okay, so less room for error, pun intended. Now, our document talks about the Room architecture, which has three main components. It mentions the Room database itself, something called an entity, and something called a DAO.
Yeah, those are the three pillars of Room. The Room database, this is like the main entry point, the top-level object that represents your entire database. It's an abstract class that you need to define in your code, and you annotate it with @database to tell Room, hey, this is a Room database.
Okay, so it's like the container for everything else.
Precisely.
Yeah.
And within this database class, you list all the entities that belong to this database, basically all the tables that it contains. And you also need to provide an abstract method that returns an instance of your DAO.
DAO, that's the data access object, right?
Yep, that's number 2. The DAO is an interface where you define all the methods for interacting with your database. You annotate this interface with @DAO, and within this interface, you don't write any actual implementation code. You just declare the methods, and you annotate those methods with special Room annotations that tell Room how to translate those methods into SQL queries.
Interesting. So it's like a contract, a specification of how you want to talk to the database.
Exactly. It's like saying, I want a method to insert a new contact, or I want a method to get all contacts whose last name starts with S. And you use Room annotations like @insert, @query, @update, and @delete to mark up those methods.
So it's those same see or ut operations we talked about before, but now they're expressed as methods in this DAO interface.
Exactly. And Room takes care of generating all the necessary SQL behind the scenes.
Super convenient.
Yep.
And the third component is the entity.
Right. The entity represents a table in your database. Right? It's basically a class in your code, and you annotate it with @entity. You can also give it a table name if you want to override the default, which is usually just the class name.
Okay, so it's like defining a blueprint for your table.
Precisely. And the fields within this entity class, they correspond to the columns in your database table. So if you have a user entity, it might have fields for name, email, password, and so on. And you can use more annotations like at column info to provide extra details about a column, or at primary key to mark the primary key of the table.
So you're defining the structure of your table right there in your code.
Exactly. And the cool thing is that you can even tell Room to automatically generate unique primary key values for you, so you don't have to manage those manually.
Nice. So that's how the three pieces fit together. You have your Room database, which contains your entities, and each entity has a corresponding DAO that defines how you interact with it. And I'm guessing to use Room in your Android project, you need to include some specific libraries or dependencies.
Yeah, you definitely need to add the Room dependencies to your project's build configuration file, which is usually called build.gradle. The exact dependencies will depend on the version of Room you're using, but it's a standard process for incorporating external libraries into your Android project.
Okay, so you add those dependencies, you define your Room database, your entities, your DAOs, and then how do you actually use Room? Like, how do you perform those CR operations we talked about?
Well, that's all done through the methods you define in your DAO interface. So, for example, to insert new record into a table, you'd have a method in your DAO annotated with @insert. And this method would take an instance of your entity class as a parameter.
So you create an object that represents the data you want to insert, and you pass it to this @insert method.
Exactly. And Room does all the magic. It takes that object, extracts the values from its fields, and generates the appropriate SQL insert statement to add that data to your database table.
Awesome. No need to write any SQL yourself. What about retrieving data?
For that, you'd use a method annotated with @query. And within this annotation, you write your actual SQL query. But the cool thing is that the return type of this method is defined in terms of your entity class. So if you're querying for a single user, the method would return a user object. If you're querying for a list of users, it would return a list user.
So Room automatically maps the results of your SQL query back to your objects.
Precisely. You get your data in a format that's immediately usable in your code without having to do any manual parsing or conversion.
Really slick. And what about updating and deleting data?
Similar approach. For updating, you'd have a method annotated with @update, and it would usually take an entity object as a parameter. Room uses the primary key of that object to identify the row in the database that needs to be updated. And for deleting, you have a method annotated with @delete, and again, you'd usually pass in an entity object, and Room uses its primary key to find the corresponding row to delete.
So it's all very object-oriented. You're working with objects, you're passing objects to methods, and Room handles the SQL side of things for you.
Yeah, it makes database interactions much more intuitive and less error-prone, especially if you're already comfortable with object-oriented programming.
Okay, so that's Room in a nutshell. A powerful way to simplify and streamline how you work with SQLite databases in Android. But our document also mentions some alternative database options for mobile development.
Yeah, it lists quite a few: Azure SQL Edge, Couchbase Lite, Realm, and a bunch of others. And it points out that these databases differ in a couple of key ways. One is how they actually store data.
So some are relational like SQLite, but others are not.
Right. Some are what are called NoSQL databases. They don't use tables and rows like relational databases. Instead, they might store data in documents, key value pairs, or even graphs. And each approach has its own pros and cons depending on the type of data you're working with and how you need to access it.
Interesting. So it's not a one-size-fits-all situation. Different databases are optimized for different use cases.
Exactly.